First of all, I think we've tried to sort of apply this perspective of architecture not as the mere sort of design of beautiful objects or like well-composed facades, but this sort of idea of trying to look at our cities and buildings as man-made ecosystems. Our office is based in New York and in Copenhagen. I have very committed colleagues. Our office is located in Copenhagen inside a former Carlsberg factory where they used to make the least exciting part of the beer, the bottle cap. I'm going to return to this because there is something interesting about how strangely these like industrial or infrastructural projects of the past seem to be perfect, sort of reinvented to be the framework of, for instance, the creative workspace of today. So that's sort of the point I'm going to move towards. But first, a few sort of takes on how design, sustainability, green thinking can actually be used not just as a moral obligation or some kind of a homework or a checklist, but actually as a design driver. And I think one of the architects that have inspired us the most in our office is this guy, Vernacular, who created the book and the exhibition called Architecture Without Architects. It was back in the early 60s, a short introduction to non-pedigreed architecture. And basically he had observed that buildings with modernism and the international style of modernism had started looking the same everywhere. On the left, the Lieber House in New York City, on the right, Hotel Royal in Copenhagen. Two completely different cities, almost like the same building. And that's because like modernism came with the advent of building engineering. Instead of daylight, we could make electric lights, making us independent of the windows or the proximity to the windows. Instead of like opening a window for ventilation, there was mechanical ventilation, making it possible to make extremely deep floor plans. And then there was like central heating and air conditioning that could regulate the temperature independently of the thickness of the windows or the orientation of the home. So suddenly, the architecture didn't do anything. It became a boring box, tube-fed by a gas-guzzling machine room of machinery. And the result was that sort of all over the world, buildings started looking exactly the same because the architecture didn't perform, it didn't respond to the climate. And Bjarke was excited by what he called vernacular architecture. Basically that all across the world, people had found ways to use the local materials to respond to the local climate in ways that would optimize the enjoyment inside those structures. Some of the examples, like the Greek villages with the white walls that reflect heat and the flat roofs where you can enjoy the cool breeze in the evening. Of course, like sort of different climates have different materials, have different sort of challenges. These windswept steps in China, where the courtyards actually provide shade from the prevailing winds in a flat landscape. So what we are interested in is what you could call Vernacular 2.0, that today we actually have the capacity to simulate and calculate and model the environmental performance of our structures before we build them. So the thermal exposure of building volumes that can tell you where it's good to put windows, where it's good to put photovoltaics, the sort of the airflow through structures and buildings. So instead of architecture without architects, you can almost call this engineering without engines. So essentially, this idea that we can, if we can sort of put more performance back into the permanent bones of the building, we can actually take that performance out of the machine room and even invest those resources into making better and more beautiful buildings. And I'll just show you some examples. And like this is the world map, as you know, the map of the nations. But sustainability, maybe this is the more interesting map, the Copenhagen climate classification map, where you see that also zones, on the west coast of the US, Africa, Middle East, sort of northern India, Australia, actually have similar challenges and therefore could also exchange experiences with each other because they occupy the same climate. So I'll show you a few examples. The first one being in Shenzhen, close to Hong Kong, the sort of the big machine room of the Chinese economy. There we were asked to a competition to design the headquarters for the Shenzhen Energy Company. And it's essentially a 1 million square foot office building in a humid subtropical climate. And basically you have the dilemma, you want to maximize views and daylight, but you want to minimize thermal exposure and glare. So we came up with the idea to design the facade almost like a pleated dress that sort of is fully open to the north, but fully sort of shaded from the south. So when you're looking towards the sunny side, you see bamboo veneer walls washed in daylight, and as you turn your head, you actually realize that it's also an entirely glazed facade looking to the least sun-exposed sides. Within this logic, you can make bigger openings, you can sort of create a stack, you can make entrances, a stack of like executive meeting rooms, north-facing, photovoltaics on the roof. And basically this very simple idea without any technology or moving parts saves around a third of the energy consumption on air conditioning simply because the geometry of the facade minimizes the thermal exposure, and it becomes a major part of the experience of the building when you're sort of moving around inside. And basically what makes this building look different is also what makes it perform differently. That it's not just you know, an add-on, it becomes an intrinsic part of the building itself. And you can see some of the images of the construction site that there's also a certain elegance to this sort of Issey Miyake kind of facade treatment. Another example, staying in Asia, we got invited to Hualien, the most beautiful place on the east coast of Taiwan. You have like the most dramatic mountains, sort of sitting basically at rice fields and on the water. And here we were asked to make a rather dense new sort of residential development. And we thought like somehow whatever we do, we can't just drop down the sort of typical bundle of Asian high-rises. We have to somehow take the landscape into consideration. And we came up with this idea that since we are very close to equator, the sun literally rises in the east and sets in the west. So if we imagine these ribbons of rice fields, if you like, or like of green, that sort of flow over the building silhouettes, the direct sun exposure is going to hit the vegetation that really wants the sunlight. And then we can actually have rather open facades to the south and to the north where you have the least exposure. So we can create like hiking paths through this sort of a man-made landscape. The result is like, even though it has quite a significant density, it almost evokes some of the sort of classic techniques of indicating sort of the sort of layer upon layer of sort of Asian landscape paintings. But basically also that you can actually have really, really open facades enjoying the view while actually blocking most of the direct sun with the vegetation. So as you move through, you actually have sort of man-made hiking paths, you have like little valleys that occupy the space between the buildings. At some point we were asked to value engineer and see if we could do the same design but just taking out all the green. I think all of you that are architects know that this happens more often than not. But we teamed up with Arab on climate engineering that we also did the Shenzhen energy mansion with. And we found that because of the evaporative cooling from the vegetation, the temperature on the balconies and the terraces of the homes would actually be up to 4 to 5 degrees Celsius, which is maybe like around 8 degrees Fahrenheit lower on average because of the humidity and the natural cooling from the vegetation compared to like a mineral or a metal roof. So we actually managed to save the landscaping because it actually had really hard measurable performance advantages. So here you see some of the space between, we start moving in to the buildings. Inside, the architecture is actually much more classic and traditional than one might think. This sort of combination of let's say like classic Scandinavian and Asian sensibilities, but of course because of the undulating roof profile, you also have a lot of like really unique apartments where you sort of benefit from the attic-like feeling of the slopes, and even the most difficult homes actually have like an incredible amount of charm that is hard to find in a modern development. So this is a project we've actually been working on for 6 years, and for quite a while, because like when you look at these images, you think, yeah, okay, but they're never going to do it. But in fact, last year we opened the sales pavilion, and we sort of submitted the construction documents, so the project is actually going to happen in the next couple of years in Hualien, and you get like really sort of charming spaces inside, and of course this sort of unusual merge between greenery and architecture. So the last project I wanted to show in this sort of safari on climate is in the city of Montpellier in the south of France. It's the hottest city in France in terms of temperature, and it's also the cradle of modern medicine because of the proximity to the Middle East and North Africa. It was the home of modern medicine. So you have like this whole heritage of really ancient elements, sort of pharmacies. The Jardin des Plantes is the oldest herbal garden for medical purposes in Europe. And we were invited in this beautiful park in Montpellier to design a museum for the human body. And it's basically a series of exhibition programs and events programs. We organized them along sort of a central spine, and then because it's basically bridging between the park and the city, we imagined it as this sort of undulating membrane where people could pass almost as if by osmosis from the park into the city and vice versa. This undulating zipper basically brings the park into the city and the city into the park. You sort of step in. You have this sort of like really large continuous floor plate, but it's broken down so it feels like individual pavilions. But then because it's the hottest place in France, and we're in a beautiful park, we want to look out, we thought like we somehow have to deal with all that sunlight. And normally when you put louvers on a facade to provide shading, the logic is quite simple, that to the south you want horizontal louvers. This is if you're on the northern hemisphere. To the south you want horizontal louvers because the sun is high in the sky. So by having horizontal louvers you can preserve the view but block the high incoming sun. But to the east and the west, where the sun comes at a lower angle, you want vertical louvers with a certain angle to hit the sun as it comes in. So that's on a traditional sort of four-sided building. But of course, when you're dealing with a curvilinear facade, that equation becomes more gradual. So basically, depending on which orientation a facade has, the ideal angle for sunscreening changes ever so slightly. So we developed this little software that can tell you the ideal orientation of a louver at any orientation of a facade. When you sort of fold it out over the entire curvilinear facade, it starts creating these patterns that remind you of human thumbprints, or some of the patterns that occur naturally in the biosphere. So since it is the museum of the human body, it felt naturally sort of intuitively right that you would have this like organic thumbprint pattern on the facade, but it's actually not designed by us. It is purely generated by the ideal orientation of a louver given the orientation of the facade. So again, this sort of idea that if wielded in an interesting way, sustainability doesn't just become more homework, it actually becomes something that you really drive a whole new design sensibility and a design agenda in the design work. So there was a lot about warm climates. Of course, like once you've identified what are the key parameters, and in a very warm climate, that tends to be how you deal with the heat and the excess heat and the glare. But once you've identified what these like primary drivers are, or what the primary question is, you haven't found the answer yet. Then you have to try a lot of ideas. And we do that by making a lot of attempts. We build a lot of models, and then we measure those models against the parameters we've established. I'd like to show you an example of this. This is Vallée du Choux in Switzerland, in the Jura Mountains. It's the cradle of Swiss watchmaking. This is our site. We were asked by Audemars Piguet to make a museum of watchmaking. And the founders, Audemars Piguet, they started their workshop in the attic in the building. You can see in the middle. Next to it is the historical headquarters. So these are buildings that are between 150 and sort of almost 100 years old. So our first intuition was that we had to fit in. So we tried to integrate the museum between the two existing buildings. We thought that would be the gentlest touch. The more we looked at it, the more it felt like an annoying newcomer butting in between two old friends. So we thought, let's go under the radar. Let's stay low in the landscape. There was a whole program of different galleries they wanted for different exhibitions. So we thought, what about making a village of interconnected galleries? Maybe they could be like a journey, like a chronological journey where you end up with a visit to the historical workshop. You know, again, like there was like more or less successful ways of doing it. Then we thought like we should just really be part of the landscape. Of course, we're in Switzerland. So you can see sort of gradually through this sort of trial and error process, like an argument matures and a design evolves. So what we ended up doing was the program of the museum had a series of galleries of different sizes, organized along a sort of a chronological journey. By coiling this journey into a compact space, we could actually, almost like a double spring or double spiral, we can fit everything within the site. We get the biggest gallery in the middle as the program dictates. And we also have the possibility to make shortcuts from one to the other, so you can follow the linear trajectory to the center and back up to the workshop, but you can also move from one to the other if you're being impatient. So then the roof follows the landscape to allow daylight and air to penetrate deep into the floor plans. So basically, as you arrive, the first thing that greets you is a view over the valley. Then you move through the different exhibits. You can pass through the workshops of master watchmakers that are sitting with north-facing light, as they've done for 150 years. And you can see how they're repairing the historical timepieces. And then maybe one thing that's interesting. Can I borrow this? Now they're all folded. Does anyone have a non-folded piece of paper? For demonstration? Yes, that one. Can I take it? You'll get it back. Excellent. You've been spending. So if you look around, you'll get it back. There's something missing in all the views, and that's that there are no columns. The entire roof seems to be floating like a spring or a spiral above your head. And that's like some of the main disciplines in watchmaking is actually, so essentially also something that design, and especially sustainable design, should be all about. It's getting a maximum of impact with a minimum of means or a minimum of material. So skeletonization is when they carve out all of the elements in the gears that they don't need to reduce the mass. Miniaturization is, of course, making the watch as normally as flat as possible. And glass is actually stronger than steel when it comes to compression, but it's very bad at tension, and since it's an earthquake zone, when, it's a little bit too crumbly, this build. Since it's an earthquake zone, it will buckle and break when there's an earthquake. But because of the circular geometry of the facade, the circle actually lends rigidity to this thin sheet of glass. So there's actually enough stiffness. Let's wait for you here. There's enough stiffness in the glass to actually carry the entire facade without any columns. So you can say almost the architecture of the watch museum also becomes part of the spirit of watchmaking. And then finally you can journey up to the historical workshop. But when you present the idea like this, it feels almost inevitable that of course it has to be like this. You're just forgetting that you had to kiss like 50 frogs before you got there. And of course, the client wanted to see that glass can actually carry steel, so we did a mock-up, and it's going to open in 2 years. Almost as a side effect, which again shows how a site or a program can contribute. The same client asked us to do a hotel right next to the museum. And since this valley is the longest continuous cross-country ski slope in the Jura Mountains, we thought, like, of course, this hotel could maybe be the first ever literal ski-in, ski-out hotel. From anywhere in the hotel, you can move out on the slope and move out in the bigger terrain. So almost like a hybrid between a ski terrain and a place for living. So and that brings me to this.